Okay, we're filling out the missing justifications for this proof. And it is a proof of the alternate interior angles theorem. Okay, it says we're starting out that L is parallel to N. And let's just highlight it, because why not? Okay, this right here is parallel to this right here. And we've got this transversal line. So they are saying, and here, let me just put the transversal, put the transversal line in. They say for number 2, angle 2 is congruent to angle 6. Where are those angles? Well, those angles are right here and right here. Okay, and they're corresponding angles. And corresponding angles are congruent when the lines are parallel. And we know those lines are parallel. So how do we say that angle 2 is congruent to angle 6? That is corresponding angles theorem. Okay? And what do we know now? Angle 4 is congruent to angle 2. Where are those angles? These right here. Angle 4 is congruent to angle 2. And of course, that's true because of the vertical angles theorem, right? Any two vertical angles are going to be congruent. So we say vertical angles theorem. Yep. And angle 4 is congruent to angle 6. Well, check it out. If we have this first statement right here, that angle 2 is congruent to angle 6, and then we know that these two angles, angle 4 and angle 2, are congruent, we can substitute angle 2 with anything that angle 2 is congruent to. Okay? And angle 2 is congruent to angle 4. So now instead of putting angle 2 here, we can put angle 4, and we've got angle 4 is congruent to angle 6, or angle 6 is congruent to angle 4. How did we do that? We did that through substitution. So we just say substitution. And that's it. Those are the justifications for this.